All right, we are moving on, and we're going to kind of piggyback on our last thing that we did, geometric functions. And we're going to talk about exponential growth functions. All right. Once again, we're going to start with a couple of parents. All right. The parent graphs are a little bit different now because we have different bases. And for the definition of this, we're going to say a function in the form of f of x equals b of x. B now, we're used to b being a kind of a horizontal stretch factor, and in a way it still is, but right now we're going to call it a base. B is a positive constant other than 1, because obviously if I'm raising 1 to an exponent it doesn't change, right? And the exponent x is a variable. Notice there's no single parent function. We could have tons of choices for b's, so we're going to have different parent functions, and on this first page we're just going to go ahead and explore one or two. Alright, so let me see if I can get just a little bit closer for these. Not too bad. Let me adjust this. Okay, so for this first one, we got f of x with a base of 2 to the x power. And remember, anytime I put a negative exponent, so if I had 2 to the negative 3, that would turn into 1 over 2 to the third, right? Negative exponents flip us over. So what we're getting here is 1/8. This is flipped over squared, so that's 1/4. This is just flipped over to the first power, so that's 1/2. This is to the 0 power. Anything to the 0 power is the number 1. Now we've got 2 to the first, 2 to the second, 2 to the third. And if I graph those real quick, you can kind of see, there's my 1, there's my 2, the second is 4, to the third is 8. It kind of runs off the graph there, right? We said to the, what, the first was, or the negative first was 1/2, right? And we're looks like we're forming that horizontal asymptote as we get lower and lower. So with this, looks like our domain goes on forever each direction. Let's go ahead and say, right? But our range doesn't go below 0. In fact, judging by this parenthesis I'm putting there, it doesn't touch 0. We can see off at the right it starts to shoot up very quickly, approaching positive infinity. Now the only thing that different the base does is it make things happen quicker. Like if I flip that over with a negative exponent, instead of being 1/8, I'm all the way down at negative 1,000. And that's negative 100. That's negative 10, right? I'm just flipping over that base, right, and giving it a power. This one's still 1. So look, we get kind of a common theme here. They're both 1. 0, 1 seems to be something that might be ubiquitous. That's a word that means ever present or always there, right? So to the first power we've got 10, second power 100, third power is 1,000. And kind of the first power already gets us up there, and we see, let's go through our 1, we see it just kind of doing the same thing, but perhaps just increasing at a greater rate, and maybe even decreasing at a greater rate down here. Same domain, negative infinity to infinity, right? Same range, right? We still don't touch 0 when we go up to infinity. Alright. Now, here's what we got. It's going to ask us the y-intercepts of each function, and you can look and see they are 0, 1. Did not matter what the base was, the y-intercept didn't change. The trend as x increases, so as I go to the right, we can see y increases at an ever-increasing rate. So let's say that. Y increases. Or it's faster and faster. We're going to say that by saying at an ever-increasing. I'm going to go over here and say rate. Alright. Will the domain be the same for every exponential function? Well, it sure looks like that, right? I gave you 2 there, and it sure looks like, well, you know what? It goes to left and right forever. So we're going to say yes. Alright. No type of transformation will affect domain. I can stretch this thing out, I can move it up and down and left and right, but my domain is always going to be the same. Will the range be the same? Alright. For every function like this where b of x, where b is a positive constant? Well, as long as we don't bring other stuff in, right? As long as all we've got is b of x, we don't have k, right? K is what's going to slide us up and down and change the range. So we're going to say yes, right? And what is the equation of the asymptote? We're going to say the asymptote, right? So horizontal line at y equals 0. It never touches that. Okay. Will the value of y-intercept be the same at every parent function? For these, yes. All right. And once again, unless we're adding h and k, right, we're just going to say the base doesn't change y-intercept. And that's it for now. Alright, so there's first page. Talk to you soon.